Hey guys, welcome back. We're doing our second experiment. These are the items you're gonna need for this experiment. This is our version of one of the experiments that we wanna explore. No, you don't have to get a donut. Donuts are for tomorrow morning with coffee. But these are the items that you need. We're actually doing an exploration. This is not an actual experiment, but we're doing an exploration of trying to figure out how we can duplicate Archimedes' screw. Yes, the screw. It's basically a screw pump, but it's like, what do they call it? Do you remember what he called it? What did he call it? The screw what? You forgot?
Yeah.
Yeah? Well, anyways, it's Archimedes screw pump, right? That we're trying to get the water to travel from the lake up into shore. So we read chapter 3 of this book, and it started touching and explaining his Archimedes screw pump, I guess, if you want to call it that. And we started developing an idea of how to do this at home. Could we see this the diagram all over the internet, but only maybe like one video or something else. But we wanted to actually explore it, and so we went out to figure out exactly the components that we needed to make it happen. And so first we started studying the screw. This is, later on we'll talk about this towards the end. We're going to talk about the screw, but we're trying to bridge, because the bridge from then and now is that this invention of transferring liquid from one section to another is exactly what led to drill bits, modern drill bits. We use them every day in construction, machinery, fabrication, and it's an essential tool that we use in building things, building cars, building bridges, building houses. Anything that requires assembly has to have some kind of bit in the process of building things. So we'll explore that later on. But first we want to do the Archimedes screw pump. So one of the things we got is food coloring. We got a drill bit, which is this one here. This thing we got it from Lowe's. It was like $7. And then we wanted to get something cheap, which was a PVC pipe. But it didn't work, because I'll show you right now how this has to be. We have to have a seal around the screw to transfer the fluid through. And this is exactly, it's a tight 3/4 of an inch. And we measured it with this caliper here that we have. And so we ended up going with the 3/4 inch auger bit. And auger bits are meant for construction to make holes in a speedy manner. They're not for fine projects. But this will work for our project because it has a nice flat surface here, and this edge here on the bit actually makes a nice seal around the tube. And so we have a vice grip on here to hold it in place, because that way we can show the actual water flowing through. So it's going to be a little bit wet. Prepare yourself with a water in a bucket, because we're transferring water from this bucket out here. So imagine this would be land, in Archimedes situation. We got ourselves a little paper towel, and we have some extra water to add on there. This has already been dirty because we went through it a little bit earlier before we started this experiment. So we're gonna take some food dye so you can show you guys can see a little bit better the water. It's not hard to see the water going through there. So We're gonna put 3 drops, or 1, 2, I think that's good. And then 1 drop over there on our extra water. And we're gonna let it, I guess, yeah, go ahead and mix it with that. Okay, mix that one as well. There we go. So, I'm gonna show you guys right here, the reason why we didn't go, even though PVC is a lot cheaper, the reason why we didn't go with this is because you could tell that there is a gap in between this, so it doesn't make a seal. And to transfer water, you want to have a nice seal to make it happen, make the actual water transfer happen. So this one, as you can see, it's going to be it's a quite tight fit. So you have to kind of screw it in a little bit and see. So it goes in and it's nice and tight. There's no movement, very little movement. So the tolerance is in there a little bit better. So we're gonna get this out of the way, and we're gonna go ahead and, well, I guess it's in there. Why do I take it out? Go ahead. Okay, stop right there. Now, let go of that. Let go of that caliper. You don't need it. Okay. Now grab the, if I do, you want to grab it with your other hand? Did you feel more comfortable with your other hand?
No.
You got it like this? Okay. So now he's going to explore the actual transferring of water. And you can see, there you go, it's working. Water's coming out right there. Keep going faster. There you go, water's coming right out. There it is, you're pulling out the water level's going down, so I'm gonna have to replenish it. Okay, you exhausted. Okay, now let me pull this up. Keep turning it. We're gonna take it out. Okay, now, so there you go. We successfully transferred water from this bowl to the other bowl outside, and that's what Archimede's exploration, or observation and development, and he actually figured out how to transfer water from one area to the other using a mechanical device. Now, what's interesting is that not only, no, don't do that, please. Not only was he able to transfer what we call, water pump from one area to another, but I'm gonna hand over the phone to my son so he can record and get on this side. Okay. Now, I'm gonna show you guys. Right there. Now, this is interesting because we think about, I'm gonna put this in here to protect our countertop. So, what's interesting is that we think a drill bit as just basically a device that makes a hole, but in reality, it's doing the same thing as over here in the pump experiment. It's basically shaving off the wood, and then transferring the wood out. So I'm gonna do a little bit of demonstration here. I'm trying not to go over the whole thing, but I'm gonna show you guys that you can go through it, and you'll see that it's actually transferring the wood all the way through. So I have to be careful not to. So that's why, see right there, it's shaving it, and it's pushing out, transferring the debris out of the hole. The hole also being over here, the tube in the screw pump. But you can see it, the debris going into the screw and out. So that's what essentially that's what it's doing, except that it's doing, the bit is doing also with solids. So we have solids, which is what we call the sawdust. So, and this debris is drill dust. So that's how we use this in everyday life. You know, in modern life, we use the drill bit as a way to make holes and continue to get out. Some bits, when you use them, in my experience, is that if the debris doesn't get out happily out of the hole, what ends up happening is that the shavings stop traveling, and it makes it hard to continue to drill the hole down, especially if you're making a deep hole. So sometimes you got to pull it out and get the debris out because it doesn't flow as easy as water. But obviously in the modern life, we also use the screw. The screw, it's almost the same idea. The only thing is that the difference is that it acts like an auger, and it actually bites down, and it grabs the side of the hole. So if you have a hole, you have the sides grabbing, not too close. There you go. You have the sides grabbing onto the sidewall of the hole. So you can see how Archimede developed two very important modern developments and tools into this into our modern life. All right, guys. Hope you guys learned something from this one, and I hope you guys learned something, and hope you guys continue to like and follow. If you guys have any ideas for further videos or explorations, please let us know. Comment below, and we'll see you guys on the next one.